Hello everyone, it is Tuesday and it is time for Tanner's massive API reviews again, where more hardware intrinsics are being added. Tanner just pointed out that I should have invited someone from Intel for this one, but I didn't know, so I didn't do it. I thought last minute for Tanner is good enough, but apparently there's more people involved now, so I need to be a bit more careful with scheduling stuff apparently. So should we talk about this anyway, Tanner, then, or? I am. I'm not sure you are. We should be. Okay, let me check. Say something, Tanner? Yeah, I think yeah, I'll figure it out. Just keep talking.
Where we added new APIs but didn't actually keep them in line with each other. And so this covers bringing vector of t in line with the other types, and then a few additional APIs that look to be effectively missing from the vector types in general. So for vector and vector of t, the first one is we should have a divide API that takes a scalar value. This can be made significantly more efficient on various platforms, and for integral division, when this is a constant, we can do various tricks to do better SIMD acceleration where we would end up doing no SIMD acceleration today. Vector of t is missing the get element extension method. It's missing the load APIs. There should actually be the store APIs too. I'm not sure why I didn't actually put them in here. But it's missing the load and store APIs. It's missing the toScalar and with element extension methods. It's missing the vector of t itself was missing all bit set. We have all the other properties. And then it's missing the operator for scalar division and then unary plus, which we've exposed everywhere else.
Tanner, can you remind me why is get element an extension rather than an instance member?
So if it's an instance member, then the first parameter is passed via a hidden byref, and you don't want to ever take the address of the vector types. It hurts the JIT's ability to enregister them. It has to do significantly more work to prove that there is absolutely no aliasing, and that it is safe to effectively treat it as a value type rather than requiring it be spilled to the stack and then accessed that way.
But that's not the case for get all bits set?
All bit set is a static.
Oh, it's a static. It's a static. Got it.
And are these load APIs supposed to return vector of t, not t?
Yes.
Okay. And do we have? I see that there are different constraints on them. Some are unmanaged, some are struct. Is that also intentional?
Yes. So the ones that are unmanaged are because we have to we're taking a pointer to them, and so they have to be unmanaged. And the ones that are struct are matching the constraint requirements of vector of t itself, which was originally done because it simplified the JIT implementation.
Okay. So that it sounds like this isn't going to make it more difficult to use, like if you're inside of a generic method yourself, because you yourself already have to be constrained to something.
Correct.
Okay.
And Jeremy, I am just quickly fixing the signature there and copying the store APIs. Only source.net didn't do terrible things when I tried to copy source code out of it.
Heute ist E-Mail dafür.
That sounds very bad when you say it like that.
You tell me another word for leader in German and I'll use it.
Yeah, that one is burned, unfortunately.
So we have both a divide operator and a divide method. Is that? Oh, so okay, one's on vector of t. Okay.
Right, and we did that in 2014. I'm not sure why we did that in 2014 because I wasn't on the team. But we did it, and that's how we've kind of just kept it ever since. Theoretically, it's following some FXCOP rule, and I think a framework design guideline to support languages that don't have operators. But we have not done this consistently across the entire BCL.
Yeah, I mean, I was involved with the design of the API. I think it was less about the FXCOP thing where you're supposed to have named operators. It was more about the fact that not all combinations of T's worked. And so we decided to just be consistent and have operators only on the vector type, where you basically can change types around because they're all extension methods or statics, or you declare them whatever you want them to declare it. And I think as we just evolved the API, it just became less and less of a thing. Because I think, I don't know, did we actually have any sort of operators on vector of t originally? I don't think we did. I think they were all added after the fact.
We have. Yeah, the operators have always supported all the types.
Yeah, I don't know. I think this might have been like the typical thing of like initial design was that, and then by the time we shipped, some design has shifted. Okay. There was certainly some controversy around certain combinations. I think the bitwise ones, for example, were super controversial due to what do you do, what happens when you use floating point, for example. But yeah, I think we might have messed up.
I also called out a couple places where we were inconsistent, and I don't think it's good for us to be consistent. So Vector has APIs named as vector byte, whereas on vector 64, 128, 256, we just called it as t. We didn't call it as vector t. Likewise, we fully spelled out square root on vector, which was inconsistent with how we did square root everywhere else throughout the BCL, where we just did SQRT. And then vector of t has constructors rather than create calls, which it represents complications in the JIT to make it efficient due to that implicit biref. But those are just those are the only remaining places where they'll be different after this.
So the only thing that is a bit odd is that you have extension methods over vector 128 on vector. I think that's the first time we have none.
Oh, I copied that wrong. It's supposed to be vector of t.
Okay, that
Sorry.
makes more sense. Okay.
I fixed up the rest of it and forgot to fix up that.
Oh yeah, we don't have vector 128 t anyway, right?
No, we do. It's just in intrinsics.
Oh, but it's not generic. Oh, is it generic?
Yep, there's vector 128 and vector 128 of t.
Okay, never mind then.
Yeah.
We have so many vector types to choose from now. Yeah, does anybody have any strong opinions on this?
No one does. Then
Yeah.
there's a couple more APIs if you scroll down on the intrinsic side.
I mean, if everything's just
Yeah.
squaring the circle, then it seems fine.
Okay, so
Yeah,
then
so
we
if
are
you-
done with the numerics part, and now we want to look at the intrinsics part.
Right. So for the intrinsics part, we had previously exposed create T, so they take a generic T rather than a concrete T, just to help users who are writing generic code. We didn't expose those for the scalar APIs, so we should just expose the create scalar of T, create scalar unsafe of T. They actually already exist internally, they're just not public. And then for vector 64, we exposed double, and we exposed create scalar for long and ulong, but we didn't expose create scalar unsafe. I think we decided not to do that at the time because create scalar should have been sufficient, because create scalar and create scalar unsafe for long and ulong are the same. But it ends up causing overload resolution issues for users when they're expecting to be able to simply copy paste code, change the size, and have it work. So we should go ahead and expose that to be consistent. And then the other thing is we exposed widen APIs that return a tuple, and which internally call widen lower and widen upper. However, that is less efficient for users who only need the lower or upper half, which has come up in a few scenarios. And so we should just directly expose the already existing lower and upper APIs. And then on the generic vector types, we're missing the one property, which exposes a vector with each element set to 1. We already had that on vector of t. We are also notably missing operators for left shift and right shift. So we should expose those to be consistent.
So regarding widen lower, widen upper, I assume that going from float to double also has to do some kind of bit twiddling, right? Like it's not a simple 0 extend.
Right, it actually has to do a conversion.
Do we anticipate processors that can go from half to float, or would we ever consider doing that in software, or is it kind of like a non-scenario?
So those APIs exist, but the support for them is not widespread enough that I think we'd want to support them directly on the vector types like this. The other consideration is that half in general, you either, most CPUs that provide half support only provide conversion support. There are some ARM CPUs that allow you to also do full arithmetic, but it's an optional ISA. And for x64, the support for full arithmetic is only coming in Intel's next lineup of CPUs. They're Alder Lake server equivalents. So it's not something that's generally available. People who would use a vector 128 of half, for example, would experience very slow code, and it would provide a negative experience. We likely should expose the raw intrinsics at some point, but we might want to consider just exposing those as taking U short and not officially taking a half type, just because the the support required for vector 128 of half. It also implies software fallbacks for everything. And that's generally not an experience that users will have a good time with once it's there.
Fair enough. Okay. Okay. Thank you.
So my question I have is, you said earlier we're not really consistent with our operators. Did we ever make a pass to try to be consistent, or have you already filled in most of the things that we're missing?
So we're consistent in the vector types. What I was saying is that the framework design guidelines say you should expose a static method named add, like ADD, to support languages that don't have operator support. Throughout the entire BCL, we do that basically only in the vector types. We don't expose, methods on date, time, or any of the integer types or anything like that that support that are named add, subtract, divide, multiply, etc. We just don't do it. We expect most languages will have support for the basic operators instead.
I mean, that would be something that would be interesting to look at. I think the only language that didn't support operators that we cared about was probably Java back in the day. Because I think VB supports it. I think F# supports it too.
Yeah.
For what it's worth, I don't think it cares that they're static. It just suggests that you have a named alternative. It could be instance.
Okay. Yeah, but basically, we're being consistent on the vector types by having the named equivalents because they've always existed. But I don't think it's worth providing those named equivalents throughout the entire BCL unless we have an actual business need for some language that requires them.
Right.
For create scalar unsafe, I see that you have long and ulong, but no double. I assume the create scalar unsafe on 64-bit values is just for consistency because it is going to be safe, right?
Right. It's just for consistency because there's no upper bits that will be undefined. The entire vector will be initialized effectively. Right. It's just because there's been a number of people who have been like, I'm trying to copy paste this code and getting it to work on low power ARM devices, and I have to consistently go and replace create scalar unsafe with create scalar and do all these minor tweaks and edits other than just find replace 128 to 64.
Yeah, it reminds me of the reverse Indianness silliness we did a while back just to make life easier for people, even though it's a no-op. So would we ever add a double overload to this?
Sorry, you cut out there a little bit.
Would we ever add a system.double overload to create scalar unsafe?
I believe we already have it.
I didn't see it in APIs of .NET, but okay, I'm also blind, so
yeah.
Maybe.
Then the intent would be that it is there as part of this API proposal. The intent of this is to be consistent across the entire set. And so if I missed double, that's an accident.
What's the difference between create and create scalar?
So create that takes one element, broadcasts that value across all elements in the vector. Create that takes n elements of type T, takes one input per element in the vector. So vector 64 of short takes 4 shorts, for example. Create scalar takes one value, and it sets element 0 to that value, and the remaining values are set to the value of 0. Create scalar unsafe does the same thing, except the remaining elements are left undefined. So it's more efficient when you're doing when you either don't need the upper bits to be well defined, or when you're going to be initializing them to some other value explicitly before use.
But if the element size is identical to the vector size, like, for example, vector 64, then you have a double versus long versus
right. Then
unsafe.
create
They all do
then
the same
create
thing, right?
create scalar and create scalar unsafe all do the same thing in that scenario.
That makes
And
sense.
it's just for consistency. That way we have the same set of types supported across all the create APIs.
Yeah, so there's a create scalar that takes a double, but there's no create scalar unset that takes a double, for example. So then those should be considered fixed with this proposal as well. Basically, we have them all.
Right.
Makes sense.
And then at the very bottom of this, there's a consideration of we expose equals and not equals operators with the semantics of all. So it's equivalent to compare, equal, all, compare, etc. We could theoretically implement iComparable and expose less than or equal, greater than or equal, and also have the same semantics of all if we wanted. There's not been any asks for that I can recall, though. It's more just a kind of open consideration of we could do this if we wanted to and wanted to count it as part of consistency.
So this may be really dumb, but if we have a create scalar unsafe of t, why do we even need the other ones?
We end up having them there's no practical reason anymore other than we defined the non-generic versions first, and then later someone came in and said, hey, this doesn't work well with generic code, can you provide the generic one? So then we went and exposed the generic ones. Theoretically, if you're not in generic code, then it avoids some amount of code explosion in AOT or JIT scenarios, since you can call a concrete implementation instead.
I see. And if you call if you use a t where the value is bigger than 64-bit, it presumably blows up at runtime.
Right, that will get treated as a constant throw not supported exception.
Gotcha.
Right, we don't, just out of curiosity, I don't think we have any elemental types that are bigger than 64 bits that are legal for use in vectors, correct? At the moment?
Correct.
Okay.
Theoretically, we could add support for int 128 for like 2 operations, but that gets into the same scenario as half, which is that it's not widespread enough to make sense.
Okay.
And not enough hardware provides acceleration, so it will end up being effectively a bad experience for users.
Sure. I'm looking at the narrow APIs right now, and I think they're sufficient. So you don't want to update the narrow APIs, correct? I can't imagine what you would want to add to it right now on Vector 64.
Right. The narrow APIs are already correct.
Okay.
Theoretically, we could look at adding narrow APIs that do a double narrowing. So, for example, going from int to byte directly. But that's likely not worthwhile, and it's probably better just to do the JIT recognition of narrow.
Okay. I'm good with this then.
What is the triple right shift again? That's the rotate and shift?
No, that's unsigned right shift.
I see.
So it does a logical shift instead of an arithmetic shift.
So basically keeps the you said unsigned. So I guess
It shifts in zeros rather than shifting the sign bit.
yeah. That's what I thought. Okay.
Which, by the way, thank you to the language team for adding that. Much appreciated.
Yeah, it's made a lot of code so much easier to read.
Yeah.
Right. I assume with vector, if you use the unsigned type, it's equivalent to just normal right shift, like it would be.
Right. For
Yeah.
for byte, the double and the triple are the same. It's only different for sign types. Since those actually have a sign bit, and unsigned types just have an implicit non-specified 0 bit as the sign.
Is the operator new?
Sorry, what?
Is the operator syntax new, or is that something?
Yeah, it's new in .NET 7.
I see. That's why the colorization doesn't work.
Yeah,
Okay.
because you've never been able to implement this operator, correct? Maybe you
Right.
have.
Prior to so the runtime has had the ability to define it since 1.0. But C# didn't support consuming it in any way. And C# 11 has added the support to both define and consume it.
Okay, and is there a well-specified behavior when you try left or right shifting floating point types?
We would effectively treat it as integral, shift and then cast back, and it would be the same. It's effectively the same as if you did .as.
Okay. So it's a true bit shift rather than like a shorthand for multiplier divide.
Right.
Okay.
So for floating point, it basically means you wreck your your value.
You can potentially get weird behavior on some platforms with floating point types, which is why Jan didn't want the reverse endianness APIs for float and double. But since these are vector APIs, the convenience of having the operators and having them have correct precedence, and the low-level nature with users already able to do and or and other things negates the downsides for this particular case.
Yeah, so I guess my other piece of feedback is, would people confuse this for an operator that shifts the entire vector rather than each individual element?
Potentially, but considering that all of the operators work per element, it's something that can be easily explained to developers.
Okay.
And we can eventually expose APIs that do 128-bit lane shifts if we wanted to, but those would be separate and exposed only as static.
Okay, yeah, it sounds like you've thought through all the different permutations that might exist for T and amounts, so I think that would be okay. And as long as we have some well specified behavior, like if shift amount is greater than 64, then something happens,
right?
Whether it's an exception or we and or whatever.
We'll end up masking just like C# does.
Okay. And honestly, people are probably going to pass literals here anyway, aren't they?
That's the hope.
Yeah. Do you actually fall back to some jump table if they're not literals?
So for shift, we can actually do we can fall back to a broadcast and shift instead. Or in some cases, we can just do a create scalar unsafe, which is just a move D instead of a broadcast, and then shift, depending on the platform. Both ARM and x64 have efficient fallbacks for this that aren't jump tables.
These are the moments when I realize that I don't speak intrinsic. It's a bunch of English words that I just heard, but
Yeah, and the theme throughout my last few questions has just been, are people going to observe something that is in line with their expectations? And it sounds like the answer is yes in all cases.
Yes. Sorry, Stephen made a funny joke in chat.
Yes.
You say funny. Is it worth me looking, or?
It's always worth you looking, Wait, does this mean that you're not looking at the Teams chat normally, so any tomatoes that we throw at you, you're not going to see?
Oh, I'll see them eventually, just not usually live.
Okay.
Yeah. Ditto when I'm hosting. It's
Exactly.
The Teams chat is the least important thing that the host can look at.
Y'all need more monitors.
Yes.
That is always true.
I mean, this is where we're heckling you during the live stream.
I mean, get Uncle Satya to double our hardware budgets. I need more
I
monitors.
wonder if anyone on the live stream is getting FOMO. It's like, whoa, what is this spicy comment?
Well, yeah.
All right, so then I guess we're done with Vector 64. And I assume Vector 128 is more of the same.
Yeah, it's basically identical, just we already had all the create scalar unsafe APIs.
I get a very distinctive C++ feeling about all of this.
Yeah. And then for Vector 128 for the create, we also have an overload that takes a lower and upper half. We forgot to expose inint and inuent there. We exposed inint and inuent for all the other create APIs.
Gotcha.
And then same for Vector 256 on that one.
I realized we're past this, but like the load APIs took an index as an int. Why did we do that?
As an inuent?
Yeah, because I mean, like you're not like passing in humongously large values here, right? Because it's an index.
So the reason is performance. Most CPUs that take an index require that index to be pointer sized. So for example, LEA on x64 in the memory addressing mode in general allows you to specify indexes efficiently in a register, but it's a full 32-bit on 32-bit platforms and 64-bit on 64-bit platform registers. So we actually have this quote-unquote inefficiency in .NET because all of our indices and lengths are int32 based, where the JIT has to do a lot of work to zero extend, or in the case where it can't prove that the value is definitely positive, sign extend the value up to the full register width, do all the incrementing, and then downcasting back to int whenever it does comparisons, etc. It's all very complicated, and the JIT does a great job most of the time, but not all the time. And so in a lot of our internal perf paths, you'll find that we explicitly cast that to uint, and then upcast to inuent from that. That way we get an efficient zero extension and efficient indexing throughout everything.
Okay, that makes sense. So it's basically kind of like saving us to do additional processing on the value that's being passed in.
Right. It makes some code a little bit more complicated in that users have to explicitly handle the cast themselves, but it forces them to consider for their performance-oriented code how their indexes are being tracked, handled, and passed around.
Cool. Unless there's more feedback, I'm inclined to scroll further.
So same thing for vector 256. And then there's just that question about I comparable at the bottom.
So why do we have 128 lower and upper, but not like a vector 64 for 4 parts? It's just not something people do.
Right. It's not. So for starters, there's no platform today where you can go from a where you can create a vector 250. There's no platform today where vector 256 and vector 64 are both supported simultaneously. But outside of that, there's even on some theoretical platform, like let's say vector like x64 with vector 512, where you could go 4 vector 128s into 1 vector 512. There's no single instruction to do that. You'd end up doing it as 2 operations where you build 2 128-bit vectors or two 256-bit vectors and then combine those into 1 512-bit vector. So it's just the more efficient thing to do.
Makes sense. All right, then I think I'm inclined to just...
Anyone have any input on the I-comparable question? And whether we should implement it and have it be treated as all or just keep it off?
Sorry, what was the question?
So there's the question of we implement I-equatable today.
Yeah.
And we expose operator equals and not equals, and they're treated as all. So it does a comparison across all elements and returns true if all elements meet the condition and false otherwise. We don't expose I-comparable today. And so there's no short, efficient way for people to do compare greater than all. They actually have to do an explicit vector 128 compare greater than all left, right, to get that result. So the question is, should we just go ahead and implement I-comparable and have it implement the same all semantics that equals and not equals does?
I mean,
Are there scenarios where we expect that you would like pass this to something that was like an array of vectors and you were trying to sort them or something like that, or would it just be so that you'd have a compare to method?
It'd just be so you have compare to, and so you can use the operators as a simpler shorthand for you just want to say if all of left is less than all of right, for example.
but I mean that doesn't make, because compare to is returning a number with a sign. So if the first element of the first one is less than the first element of the second one, presumably you're already at less than. And then the second element could be greater, but it doesn't matter, you're at less than. Like it has to produce a yes, no, or less, equal, or greater. And unless it's going to be an unstable sort where mixing some are less than and some are greater than always produces 0, it seems that you're just dictionary sorting the values where 0 counts as the first letter. and it feels weird, like a thing that we're back forming.
Okay.
So
It
I
does
wouldn't
feel a
do it
little
unless there's a
weird.
very strong need.
What about just the operators and not the comparable?
But I mean, what's it mean to say that one vector is less than the other? Like
All
if you're in
elements are
Every
less.
element.
Yeah.
Yeah, it returns false a lot. Like greater than and less than for like random input would basically always return false, right?
So-
like if it's very specific situations where everything is item-wise greater or less.
Right. So I don't like it because it means that if A less than B, else if A greater than or equal to B, you haven't actually covered all cases.
I mean, let me introduce you to Nan, I guess. But yeah.
Well, I mean, that's not
what
necessarily
are the
success,
use
but
cases for it, other than slightly simplifying code in the rare case where you actually need those semantics? I mean, the places where I've seen us doing it, it's basically you do a less than or greater than, and you get back a new vector, and then you're checking that vector for whether it's all zeros or whatever.
Well, some of the most common cases are things like you're typically doing something like check bytes in ASCII range, where
Right.
all you're doing is you're checking an input and you're saying, is everything less than 0 or is everything greater than 0? That way you know everything's non-negative. And
Did
so
we have the JIT recognize that pattern though?
So you have to do vector dot greater than all left vector s byte 0, which is all the more less readable than just check is greater than or equal to vector s byte 0.
I mean, if you, like if you know you're working with vectors, maybe the operator would make sense in context, but to me it feels like you're being cutesy with the operators, and if you don't actually know what the type is or what its semantics are, the fact that the inequality relationships don't actually make sense anymore because basically every vector is nan, I think does more harm than good.
I would also, I mean, I'm only semi-experienced in the vector APIs, but vector whatever t dot greater than returns another vector, right? So I would personally expect that the corresponding operator would also return a vector, not a bool.
Well, so we've got compare greater than, which returns a vector,
Right.
Which would really be ideal, but previously API review has said, don't return vector types from the operators, only return bool. And then there's compare greater than all.
Right, but the all,
which is what equals and not equals does.
Right, the all makes sense to me. Like it's saying, hey, there's something special here. You're combining all of them. Okay, that's what gives you the bool. But there's no all kind of implicitly in my mind as part of the operator. So the operator more closely maps to the greater than, in which case it returns vector. And if we don't want to return vector from the operator, then I don't think we should have the operator.
Okay.
I agree.
I think it's generally bad to have operators where you need to read the manual to understand the semantics, right? It should be somewhat intuitive what it does. And as soon as you can define them in various possible ways, it's probably not a great operator. Which I think it kind of implies that this is what's given here.
Yeah, if I were code reviewing this, like if I were code reviewing something that used an actual less than or greater than operator against two vectors, I would be, from a code review perspective, it wouldn't be immediately apparent to me what was going on. So I don't think it actually improves usability to add it.
Okay.
But I am but one voice.
Yeah, I could also even if I would probably assume it was item-wise, but I could see someone thinking that most significant bits matter or something if you're interpreting the vector as a whole. It'd be weird, but that would then mean greater than implies not less than or equal to.
Cool. Anything else to add? I don't understand what this means. I have no idea what I've done wrong. I guess I'm
most likely you ended up hitting some site that caused you to automatically switch to your alter ego of your brand new, beautiful emo _ Microsoft GitHub account.
Oh
Yeah,
my
you're
God.
signed into GitHub Enterprise, not GitHub.
Oh my
Which
God.
should not
I
have been the
hate
same
that
domain.
so much.
It drives me nuts.
Okay, great. So
You should have a work profile set up. That way,
That is my
you
work
can't
profile.
sign.
but
Well, you should. Right, you should be browsing on your regular browser, not your work profile browser. That way, you physically cannot sign into the enterprise account.
yeah,
But
you
the
say
problem
that,
is,
but
if
then
we use our regular browsers, we can't even look at things like PowerShell source code
Yeah.
because it forces us to go through enterprise login.
Well, then
That's
you
why
just
you just
open.
Control Shift in for incognito mode, and then you can browse it all without signing in.
Yeah.
It's so bad, and then you want to comment, and then I just like give up
Like-
until I can get to another machine.
We can, if you're having trouble, Emma, we can always post on your behalf if needed.
well, that's funny. I can of course sign in. Like, that's not my problem here, but like, it's just annoying.
Yes, they should have just been entirely different GitHubs.
Well,
Oh, they are different GitHubs. It's just once you go to Enterprise, it forces you onto Enterprise until you sign back out.
Right, but if GitHub was GitHub and enterprise.github.com was different, then they could have different scoped cookies and they wouldn't know about each other. Or it was githubenterprise.com or whatever.
Or even if it just took like a single click to switch accounts, like it does for a lot of other things.
Yeah.
But the most annoying part is it happens automatically logging me into the enterprise one, and then I have to go back. I have to go through the
yeah,
whole two-factor authentication and
it's not
Yeah,
great.
be
Hell yeah.
careful. Don't click bad links.
exactly.
If you use Firefox as your primary browser, which means you can't sign into any Microsoft assets, then it's clear. If you're in Firefox, you're the good you on GitHub, and if you're in Edge, you're the bad you on GitHub.
Let's just be thankful that it's not github.sharepoint.com. Okay, so there's that.
That'd be better. It'd tell you not to use it.
Emo, you've cursed us. You've doomed us.
You're welcome. This URL, the GitHub URLs need more GUIDs anyway. All right, so then closing this one. Oh God.
So for like we discussed in the initial AVX-512 proposal, VL is a kind of special ISA. So there is a single CPU ID bit that identifies it. But when that CPU ID bit is there, it means that every AVX-512 ISA that is supported has a VL extension to it. So if AVX-512F, which is the foundation, is supported and the VL bit is set, then there is a VL extension to the base ISA. Then if AVX-512BW is supported, then there is also an AVX-512BW plus VL extension on top of that. So one bit that represents potentially many ISAs. Kind of a multiple inheritance type scenario, which we don't have a good way to model in the .NET type system unless we had the foresight and had designed all these APIs at a time when interfaces and DIMs and static interface members existed. In which case we could have done weird multiple inheritance things and violated all kinds of other framework design guidelines, but we didn't do that. So the proposal here is for the vector length extension ISAs to be a nested class within the parent ISA, much like we currently have the x64 nested class today. It would follow the same rules. So AVX-512F contains a VL nested class. AVX-512BW inherits from AVX-512F. It has a nested class also named VL, which inherits from AVX-512F.VL. So it follows the exact same model as the x64 setup.
Okay, I think that makes sense, but yeah.
We then get into a slightly interesting scenario where we would have AVX-512F.x64 And theoretically, we could also have AVX-512F.VL.x64. Or we could have AVX-512F.x64.VL. I think the former is better than the latter, though. And there's not currently any scenarios that I've encountered where that's going to be a consideration. It's just a potential future consideration as part of this setup.
And you don't foresee any cases where we have to do a natural act to hide anything, right?
No, I don't think we're going to have to do any unnatural acts to hide anything. You just might get into, you might have to access a triple nested class to access a 64-bit specific intrinsic on some future ISA extension or proposal we go through, if there happens to be some instruction that is 64-bit only. But overall, most of the time you will need no more than a double nested class where the second just 2 letters. It's just .pl.
So are all the methods that you have here already reviewed as part of the other one, or are there net new patterns?
Yeah. So all of the names here have been reviewed. So VL, the vector length extensions in particular, they so with the original SSE through SSE 4.2, everything was 128 bits. When AVX2 came out, or when AVX and AVX2 came out, they extended the entire ISA to support 256-bit instructions. So all the instructions from SSE through SSE 4.2 now had a new overload that supported vector 256. There were a few new instructions entirely unique to AVX that were also exposed, and they had 256-bit support, and they simultaneously added 128-bit support. With AVX-512, AVX-512F effectively added 512-bit overloads for everything that was SSE through AVX2. However, it also added some new instructions which were unique to AVX-512+. However, rather than exposing 128-bit and 256-bit versions simultaneously, they locked those away under a separate ISA named VL. And so this is basically everything we reviewed from AVX-512F. But instructions that are unique to AVX-512 and so it's their 128 and 256-bit versions.
So that makes sense. I mean, that's just the way ISAs are being evolved, right? So that's just the relative you have to model. But I was more curious about the naming rather than the combination of, I guess, type sizes.
Right. These should all be names that we've already reviewed following existing conventions. It's really just taking them and exposing the 256-bit and 128-bit variants of it.
How do some of these APIs differ from ones that are already there? Like these convert to vector 128 byte. How does that differ from the existing as byte or as bytes, whatever it's called?
So that one is doing an actual conversion. So as byte does a no-op cast. It takes the bits and literally reinterprets them from int to byte. So there's no bitwise change across the entire vector.
This doing like per element truncation or saturation or something?
Yes, and then packing it down to the correct size, removing the unused and unnecessary bits.
I see.
So it's actually taking an int32 and truncating it down to a byte element-wise.
Got it.
So it's like a narrow than a widen.
No, it's a narrow. But this one in particular does a double narrow. So it goes from vector 256 of int, which has 8 ints, and then it truncates it down to 8 bytes, and then the upper 8 bytes are set to 0.
Okay, got it.
And then similar with the long, it's going to take those two, set the lowest to 8 bits of each element, and then the remaining.
Tanner, you're breaking up.
Sorry. And then the remaining 6 bytes are going to be set to 0.
And the current as ones are just reinterpret casts?
No, the existing elements are truncated. So for the long, you've got 64 bits per element, and each element's going to truncate down to a byte size, so 8 bits. It's going to pack those into the lowest 2 elements of the new vector, and then the upper 6 bytes are going to be set to 0.
That's the new methods that are here.
Yeah.
Yeah, but the existing
the as
conversions are just reinterprets.
Yeah, the as APIs do a reinterpret cast.
Right.
And then naturally there's the saturation versions, which rather than truncating, saturate to 255 if the value is too large. And then same with the signed ones where they saturate to T-min and T-max value rather than just truncating.
This all seems reasonable.
Yep.
Okay, cool. Then I guess. Yeah, and I'm not doing that.
And sorry about my headset cutting out. It has this interesting feature where it tries to detect if I set it down, and it turns itself off if I do that. And apparently I tilted my head too much into my arm, and it thought I put the headset down.
Excellent.
Are they
Yeah.
Sony's?
No, it's a Corsair.
Yeah, I recently turned that off on my other headset because it every now and then I'd put it down on the table, pick it up, and then it would find some random paused YouTube tab in my browser and make it start playing. And it's like, okay, like, stop being clever. Only do what I tell you. That's how I feel about most automation. I really am a Luddite, aren't I?
And you work in software. That's just amazing.
I mean, you missed the Jeremy and Scott Hanselman show of him making fun of all of my antiquated technology choices.
Yes.
I mean, he's not wrong.
We were
probably.
doing some IPA longs in a museum, practicing for the Ignite talk the other day with Jeremy's, ancient laptop that probably is older than he is.
It does 720p. It's not like museum worthy.
Excuse me, use a trackball. Like, how is that not museum worthy at this point?
Trackball is the best. My wrists so much stopped hurting after I switched to a trackball. Assigned to me by Ergo.
See, I do this thing where I don't move my wrist, I just move my whole arm. Works great.
Pro gamer.
But then your headset turns off.
Can't have it all.
Yeah.
Yeah, but my entire PC lights up blue, so you win some, you lose some.
Yeah, my machine is also very pretty. The only problem is that it heats my room unreasonably.
So speaking of base addresses and indices and things like that, again, just going through the APIs you were just looking at, I see scatter gather on there, and the indices are taken as signed.
So scatter is special. Scatter is very special.
Okay.
In both how it's encoded, how it's used, etc. So in particular, it actually takes a signed 32-bit or 64-bit, depending, input that allows negative and positive accesses from the base memory address.
Right. Okay, so that's intentional is what I'm getting.
Yes.
Sounds good.
It's also an API that can be very slow if you're not using it in pretty special and specific scenarios, just because it's doing, effectively random memory access and has to do security checks and access checks for every address it's touching. So
yeah, I was reading the docs for it, and I'm like, yeah, this is a thing.
Yep. If you know what you're doing, then it can be super useful for like MLNet or general machine learning sparse APIs. But if you're not careful about it, it can also easily provide worse perf. So you got to be careful.
Okay, awesome.
All right, so for this next set, so we reviewed AVX-512F, so that's the foundational APIs. There's also 3 additional ISAs that are kind of part of what's called the x64 version 4 baseline. So kind of like how ARM has 8.0A, 8.1A, etc. A couple years ago, Clang, Red Hat, AMD, Intel, and a few other people got together and formally defined versions for the x86, x64 spec. And you've got the baseline specification, which is a machine from approximately 2004, 2003, 2004. That says SE, SSE2. You have V2, which defines everything up through SSE 4.2. V3, which defines everything up through AVX2, FMA, and then BMI 1 and 2. So roughly a Skylake era processor. And then you've got V4, which defines AVX512F, BW, CD, DQ, and VL. So this is the 512-bit variations of the other 3 kind of foundational AVX512 ISAs. BW specifically stands for byte and word. So it's most of the APIs that support byte, SByte, short, and ushort. DQ is double and double word and quad word. So it's going to be most of the APIs that support int, uint, long, and ulong. There's a little bit of a nuance there in that they for those ones they also provide a few of them in the foundational APIs, just because most of float and double are part of the foundational as well, and you have to have a few of the 32-bit and 64-bit ones to provide full parity there. And then CD, which stands for conflict detection, I think, and it's supposed to largely be used for helping resolve various masking operations and helping ensure everything gets fixed up correctly. None of these really have any new or special or different names either. The same names we've used through in SSE all the way up through AVX 512. So we've got absolute value, we've got add saturating, align right, average bytes, convert bytes and S bytes up to short. So it's effectively a widen operation, but notably also a widen operation that can go from vector 256 up to vector 512, rather than one that goes from vector 256 to 2 vector 256s. max and min APIs, multiply add adjacent, multiply high round scale, multiply low, pack sign saturate, pack unsigned saturate, etc. The ones that kind of follow new names are going to be the ones closer to the bottom of each class. The ones that are under the AVX-512 comment, as those represent APIs that are new and unique to AVX-512. So there is no corresponding equivalent necessarily for the existing, although many of them follow naming conventions that we've already put in place. So some absolute differences widening, still using the same some absolute differences base name and then the widening suffix, just like we did on ARM64. We've got the convert to vector 256 byte with saturation, which is similar to the convert to vector 128 byte with saturation. But now it's a downcast from 512 to 256. The variable left shift and right shifts for vector 512 for short and ushort.
Did you stop talking, or did the headset cut off again?
No, that was just the end of my
Okay.
statement there.
So,
What's
sorry, go ahead.
var 32 by 16?
So for permute var, we are doing sorry, I have to remember. This follows the existing convention, but I have to remember why we named it this way.
I guess really, is this a pattern we've already used the name of?
Yes. This is following the existing pattern.
Okay.
Basically, one of them specifies how many elements you're doing in each shuffle, how many elements exist per lane, and then how many bits per element. So I believe this one is specifically saying it's doing a full 512-bit shuffle rather than permute var what would it be 1616, which would be permute at a 256-bit lane width, and then permute var 816, which would be permute at a 128-bit lane width.
Okay. I mean, like, looking at it,
also,
I don't know what permute var does, but if we've used that name elsewhere, then
it also it also closely matches the C++ name. Yeah, it's and the instruction. It's the permute APIs are interesting APIs. Mostly because you've got the full vector width permutes, so you can reorder elements any way you want, and then you've got permutes that work on two 256-bit lanes, so you can shuffle anywhere within a single 256-bit width vector, and it will do that twice within a 512-bit vector. And then you've got one that will do the same thing for 128, but 4 times within the 512-bit vector. Depending on if you want to effectively unroll a loop 4 times, or whether you want to operate within a full, 32 inputs.
kind of an overall question about this class, which relates back to what you had mentioned earlier. So this class is the BW class, correct? And
Yes.
because VL is a nested type on the base class, VL is going to be exposed through here. So we're saying that BW implies VL?
Yes, and there's actually a set of VL ISAs basically corresponding to these APIs, but taking, so basically corresponding to the subset that's under AVX-512 that takes 128 and 256-bit. But I hadn't gotten to getting that proposal up yet just because I had been busy moving. So we'll get to that at some future API review, and it will probably be basically as fast as the last VL review was.
So unless there's anything more, then should we just approve this, or are there more questions, considerations, dreams, hopes?
I see. So for APIs like shift left logical, shift right logical, we have overloads for both short and ushort, for instance. Does that match what we did previously, or did we always?
What do you mean?
So we have methods that are called shift left logical, for instance, that take both short and ushort as inputs, vector of short and vector of ushort. And does that match what we did on other API sets as well? Instead of just forcing the caller to
Is Levi cutting out for anyone else?
Nope. I can hear him just fine.
Okay.
Sorry, I heard you say does it track, and then I saw you talking, but I couldn't hear anything.
Sure. Does this match what we did on other API sets where we expose both vector of short and vector of ushort, for instance?
Yes.
Okay. So there's consistency all the way down. Excellent. I have no other comments on this end.
There's a typo in pack unsigned saturate, but yeah, I don't even know. It looks good though. You got to search for unnined without the S.
We haven't done the lane stuff though, right? That seems new.
Which no, we've done the lane stuff. So that just it basically treats it as a full 128-bit integer for that type. So shift right logical 128-bit lane is going to effectively shift each 128-bit integer within a 512-bit vector over by the number of bytes.
Now we just need some hardware that can take advantage of this.
I have hardware that can take advantage of this.
Well, you do, but I want hardware too that can take advantage of it.
You could get the new the new Zen 4 CPU.
Oh yeah, because upgrading my CPU last year didn't blow my budget.
Clearly, we need a hardware refresh to test out the new API.
Yeah. I was about to say, if you work with Tanner, that means every 6 months is a hardware refresh.
Tanner now has the fastest build across all of us, which makes me jealous.
The only other new concept would be so near the in the DQ API, There's some new APIs called range restrict and reduction transform, which didn't have existing concepts elsewhere.
These guys here, range restrict scalar.
Right.
I assume that's just an expansion of the words that the ISA wrote down of what their like 6-letter nonsense turns into.
Yeah, they've got VRange PD, which is range restriction calculation for packed pairs of float 64 values.
Obviously.
Is this a clamp?
Yes.
Okay.
It is. So it's a little bit more complicated than a clamp. So in particular, it can SSE2 or SSE and SSE2 exposed min and max. Those min and max APIs effectively are just doing a less than B question mark A colon B type operation. So it doesn't correctly take into account nans or negative zeros or anything else. Range restrict allows you to correctly implement IEEE 754 compliant min, max, and other operations using a single instruction. So you can correctly do min, max, min for absolute inputs, max for absolute inputs, and you can control how the sign interpretation is handled. So you can do basically any combination of min and max that you wanted, whether it's IEEE compliant or not, and get the correct behavior for it. So it's a little bit more complex than just clamping, which is why it's called range restrict instead.
So you don't get to specify the ranges, but control presumably is saying which of in operations you're doing.
Right.
And so this is choosing elements across left and right?
Yes.
Okay.
A while back, Tanner, you had talked about an attribute that we could put on parameters that said, like, hey, you really should be passing a literal value here. Did that ever make it?
Yeah, so that analyzer exists. It's just not been merged yet. It wasn't ready for .NET 7. As soon as it's in, we're going to be going and slapping it on all of these byte immediates that actually require them to be immediates to be efficient.
Okay. So we'll just assume that will come at some future review then?
Right.
Okay, cool.
So the attribute itself just hasn't been checked in yet?
Right.
Okay.
And then the reduction transform, that one's vReduce, and it's perform reduction transformation on packed float values. And what it does is it subtracts a number of fraction bits specified by the control field. So it effectively allows you to, for the result in an IEEE compliant manner efficiently, so you can do efficient reductions. Like let's say you're trying to reduce to the range of negative pi to positive pi, so you can efficiently do trig functions. This allows you to more efficiently do parts of that, so it's just altogether more efficient. And you have to do less conversions out of the floating point domain and into the integral domain. You can just do everything directly as a floating point. There's a lot of really cool instructions that are part of AVX-512 that will, if your hardware supports it, will make many math algorithms significantly faster.
Yeah,
especially especially when looking at like NaN handling and stuff. There's an entire API called FixUp that allows you to be like, if the input is any of the special values, so -0, +0, NaN, positive infinity, negative infinity, etc., you can just do a table lookup to resolve it. And you don't have to do like 12 different comparisons and branches.
Yeah, while you were talking, I was looking at some of the other instructions, like the conflict detection one here, which is rather interesting. I can definitely think of some use cases for that.
Yep. And then VP turn is probably the one that will get the most use out of throughout the BCL, because it allows you to do any 2 bitwise arithmetic operations as one instruction across 3 inputs.
Yeah.
But yeah, that's the rest of the APIs here.
Don't each of these new classes, aren't they supposed to have a static new is supported?
Yes. I thought I'd put that in there. Apparently I did not. Yeah, there's an implied is supported and an implied x64 base class and an implied x64 nested class and an implied nested VL nested class. Although we'll be reviewing the proper VL nested class here probably in a couple weeks after I can finish getting that proposal together.
What ISA is a VP turn log under?
Foundational, I believe. I think it's just F.
Okay. So it would be on the base class that we already approved then?
Yep.
Right. And so the VL ISA is going to be all of these same operators, but for smaller vectors, correct?
Yeah,
If appropriate.
Specifically all of the APIs that are under the AVX-512 comment. The ones that are under SSE-SSE42 or that are under AVX-AVX2, those ones are, what's the word I'm looking for? Those ones already exist for 128 and 256.
Well, I guess for things like the conflict detection one here, right? Detect conflicts.
Right.
How would I access the narrower vector versions of these?
It'd be AVX-512 CD.VL.detect conflicts.
So
once we review and
okay.
approve.
Got it. So AVX-512 CD.VL, I guess, will be a subclass of AVX-512F.VL?
Yes, just like
Okay.
the x64 nested classes work.
Got it. Okay, that makes sense. That's what you were mentioning earlier. Okay.
Right. So it follows the same model, and users can expect similar access to nested APIs and similar is supported semantics between all of them as to what they're already used to.
Right, so meanwhile I already approved the API because it doesn't seem like we're going to say no to it. Anything else, or can we consider this closed?
There were comments about is supported. I think Stefan found a typo, but that's all. Like, we'll fix it in post-production.
Yeah, I mean, those are the things that we should probably not ship, but that's fine.
I already fixed the typo. I'm not putting in all the extra missing API.
All right, so then
So there's another vector API that's currently marked ready for review if we want to touch that. It's narrow with saturation. Yeah.
there's also this one here.
Yeah. I think that one's from Steven. So for this one, there's just a request that we expose XPlat APIs that do narrow, but specifically they narrow with saturation because all the platforms we support it. And if a platform doesn't support it, it's trivial to emulate efficiently. So it's literally just narrow, but saturate to the min and max rather than truncate.
Yeah, this seems fine. We've already found the need for this within our own code.
Yeah, and there should notably be vector of t in here as well. I thought I had asked for that, but yeah, I did. It just got missed. So the same set of APIs, just on vector of t, taking vector of t as part of the consistency thing.
So narrow with saturation is if you have the ulong to uint, if it's 6 billion, it turns into 4 billion.
Yeah.
Okay. Instead of 2 billion.
Yep. Basically, it's clamp to target min max and then truncate.
Yeah. Check to cast, catch, assign to whichever side you failed on.
Yep.
Okay.
Is there precedent for us detecting whether a particular operation can be hardware accelerated as a single instruction? Or do people just not know?
People are able to check if the type is generally hardware accelerated via the is hardware accelerated, but there's no way to check if an individual method or even an individual method with taking an individual type as the input would be single instruction accelerated. In general, it can be expected that most things are accelerated or done as optimally as they can for a given platform, within some limitations of, due to needing to ensure cross-platform determinism and other things. But these are performance-oriented APIs under the system runtime namespace, so or a special API in the numerics namespace, because we didn't have an intrinsics namespace back in 2014. And users are expected to profile, measure, and confirm that their code is actually more performant.
Okay, but I guess one of the things I'm getting at is I'm pretty sure that Intel processors don't have narrow with saturation for unsigned values, correct? Only signed?
They do. It's a pack. Yeah, it's called pack. Yeah, pack unsigned saturate. It's AVX or no, SSE2, SSE41, and AVX2.
Oh,
So
yeah,
it's,
SSE4. Okay, yeah.
Yeah, VPAC USWB, VPAC USDW.
Okay.
Out of curiosity, with vector of t, is that going to light up with the AVX-512, like with?
So that is a discussion that we're going to have with the Intel folks, and we're going to have some more determining how exactly we're going to do that and support that. implicitly widening to 512 bits, even when your hardware supports it, can come with interesting considerations that may make it a loss for small inputs, even if it's a win for big inputs. And so we're going to be discussing whether that's automatic, whether it's opt-in via an environment variable or config knob, whether it is something that the JIT can use PGO data around to maybe allow different size vector of t's between different methods. So let's say that you had like string index of, and the PGO data, the dynamic PGO data says the most common input is, over 128 characters long. Then we could make the decision that using 512-bit vector of t is the most beneficial. But if you're doing something like, I don't know, in UTF to UTF-16, UTF-8 to 16 transcoding, and the most common input's only like 32 characters because you're doing names, we could decide to do 128-bit vectors instead. So we're looking at different possibilities on how to optimally handle everything and ensure that users can still get 512-bit vector support on vector of t, but without causing massive downsides for arbitrary code.
Cool. Thanks for the explanation.
So then you said earlier, like, this corresponding API should exist for vector of t. Is that what you said?
Yes. Yeah. Yes. Just exact same API. Just find replace 64 with empty string.
So looking at these, so to take that first method as an example, narrow with saturation from short to S-byte.
Yeah.
How would I do narrow with saturation from short to byte? Because that's the thing that Intel actually does.
You'd end up having to probably do a comparison and then truncate.
So I'm wondering if maybe, given that Intel, for instance, supports narrowing from vector of short to vector of byte or vector of S-byte, like, do we actually need two different overloads for this? So narrow to byte or narrow to S-byte with saturation. Because the min and max are different for the two APIs.
Right, because you're either considering signed or unsigned.
Right. So
I think if we're crossing the signed unsigned,
well, so I looked through the documentation just now, and the input is always treated as signed, always, and the output can be treated as signed or unsigned. So that means, according to Intel, the input is always vector of short. Vector of u short, there's no equivalent.
right, because unsigned saturation is just a clamp and narrow.
Right. But there's no way, for instance, to so if you have a vector of u short, say, and you have u short dot max value somewhere in there, it as an element in that vector, and then you say as short, and then you call narrow with saturation, it's going to be treated as -1, which is going to get turned into -1 or 0, depending on whether the output is signed or not. And I don't know how to reconcile that with the API shape that's being proposed here.
So these APIs are just doing the narrow with saturation from same sign to same sign. And I believe on AVX-512 there are new APIs that do exactly this as well. And then for the case of going from signed to unsigned or unsigned to signed, we'd have to discuss that in the future.
So yeah, I just put in chat the existing Intel APIs that are narrowing, that are on SSE4. Again, there's signed to signed and there's signed to unsigned, but there's no unsigned to anything else.
Right, there's no unsigned to unsigned or unsigned to signed. But this would only be covering unsigned to unsigned, and that's the worst case fallback of a comparison, a narrow, and a blend. So it's an efficient fallback. That's
Right,
going to
but
take
if-
3 cycles.
Yeah, but if we want to introduce a signed to unsigned method in the future, how would we do that? Because we can't overload a method in C# just on the return type.
Right, I think we'd at that point have to come up with a different API name and probably call it something like narrow with signed saturation or narrow with unsigned saturation.
Well, that's why I'm suggesting why don't we just tackle that now?
Oh, you're saying just right now call these narrow with signed saturation and narrow with unsigned saturation.
Yeah, or specify the actual elemental type in the API name, or something like that.
I think it'd be better just to call it with signed and with unsigned.
Okay, and signed and unsigned in that case would control the output, but not the input.
Yes.
Okay.
Yes.
Yeah, that's fine by me.
So that's narrow with signed saturation would return S byte, and narrow with unsigned saturation would be vector of byte.
Yes.
Yeah.
Sounds fine to me.
So
I'm fine if you just put that as a note at the top.
yeah, I was about to suggest that because it's a lot of these things. So basically,
And then in software, we'll do whatever, like Tanner said, whatever blending is necessary to make like U short to byte work correctly.
Yeah.
Okay. Because that was the other thing that bit us when we were talking about the narrowing operators, like something that looked like it was going to be a single instruction ended up taking like 3 or 4.
Yeah.
And I guess that's what you had said, Tanner, about like this requires profiling and looking at the output.
Right. And with any performance API, you always have to profile, measure, and often even profile and measure across releases. You will generally get good performance and generally better than Scalar, even if you're doing a 2 to 3 instruction sequence. It just may not be the most optimal thing for some platform, but oftentimes you're at least going to be profiling and measuring and testing on the platforms that you are directly targeting and caring about. And other platforms, like let's say you're not ready to target WASM directly yet, will still get the acceleration. It will still get good performance. It just may not be the best performance until you're ready to go and look deeper at it.
Right, and that's fair. I think like we probably have a much more strict analysis of what we're able to tolerate, compared with the rest of our customer audience.
Right. There's a lot of customers that will be like, oh, a 16 times win, that's amazing. I'll take that immediately.
Oh,
and
yeah,
even if they could theoretically get a 64 time win, if they like hand tuned everything, you're at the point of like, I already went from 16 milliseconds to 1 millisecond. Is that extra like 0.75 milliseconds that I'll get on top of that worth it? And many people will just say, no, it's not. It's not worth it for the time. Whereas we in the BCL, we're actually like, every quarter millisecond actually matters for us and our customers.
Yeah, so that is all to say, like, I wonder if, maybe separate from this, there's something we could consider where we could maybe annotate, if nothing else for our own internal use, annotate some of these APIs as like, hey, this doesn't directly correspond to an intrinsic.
Yeah, there's definitely potential for like some kind of performance analyzer that goes and says like, oh, you're doing this, consider doing this instead for better XPlat performance.
Right.
Things
right.
like refactor your move mask slightly and things like that.
Yes, exactly. Because if we have something like that and we can use it internally, then that gives us, I expect that some percentage of our external audience would also find that very interesting.
Yeah.
And I know there's going to be, a bunch of kind of engineering as well around that, because there are some things that we can only do because we've made assumptions about the inputs.
Yeah.
Okay, cool. So the only feedback then was with signed with signed saturation and with unsigned saturation.
Yeah, it sounded like it.
Okay.
Sweet. So we're then done with this one?
Yep, and I don't think I have any other ones right now.
Yeah, so there's only the one from Steven, I think, that's somewhat related. Steven,
It's related in that it's a API that's planning on using vectorization.
Right.
I can talk to this one if Steven's not here.
Yeah, he's not, but yeah, feel free.
Okay, yeah. So we have the index of any APIs, and internally we have vectorized paths if you have up to 5 values. Now, if all the values you care about are in the ASCII range, then there's a vectorized approach we can take. But it requires a little bit of time to pre-compute a bitmap or a lookup or something. And that's why we're considering adding a new API here so that you can avoid this pre-computation cost when you want to speed up index of any over like whole ASCII sets. And if this is the case, then you can start using this operation wherever you want to check if the entire input is only legal characters. For example, we have that in ERI, in HTTP, the ASP.NET has use cases for this, or like regex.
How does this help speed stuff up?
So the index of any values, right here, it's a struct. It would pre-compute a bitmap then the vectorized path then uses to scan the input. So we can check 16 characters at a time whether they all fit into this bitmap of ASCII values.
How? Okay. So it takes a ref struct as a parameter, but it itself is not a ref struct.
Yeah, like how are you handling if somebody gives you 1,000 items?
Yeah, so we don't care how many items are in the lookup as long as they're all in the 0 to 127 range, right? So in this case, if you tried creating this ASCII values and gave us a non-ASCII value, then we just throw when we pre-compute the data.
I guess repeats collapse, so
yeah.
So you're making a struct that has just a preset like 256 item state or 256-bit state.
Yeah, so this specific thing, internally, it would really be a vector 128 of byte. And then we can potentially have other state just to speed up the scalar path if the inputs are short.
So the first problem that I see with it is you have a nested class that somebody needs to interact with. That's
Yeah, so one
not
of the
allowed except
questions
for intrinsics.
one of the questions for review is like, where do we put that? Right now it's just nested there, but we don't know a good place for it.
I would honestly, so I'm seeing an API hanging off of memory extensions that tries to interpret a RAW's byte as text, and I immediately become like mentally hostile to that, because RAW's bytes are binary data. Memory extensions should not attempt to think of them as text whatsoever.
Yeah,
What
those
my
need to be on like UTF-8 or something.
Yeah, it wouldn't be UTF-8, it would be somewhere else. But yeah, like why not just have an actual type like ASCII bit or ASCII map, something like that, put it under system buffers wherever, and then hang index of any except blah 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 off of that. That way we would leave memory extensions alone.
So that was an alternative we considered at some point in this issue. I believe Stephen suggested if we can just hide that as extensions on this class. So from a user perspective, all the index of any operations look the same.
But they don't look the same because you're already involving a bitmap type.
Right, so this bitmap type you would store in a static read only or something and pass that as the needle. So, whereas with the like dedicated class, you would kind of turn it around to the point where you now have some pre-computed needle dot index of any of haystack.
Which is actually good when you're reusing a needle over and over again. One of the complaints that we get right now in system string is if you're trying to do a culture-aware search for text, if you say that you call string.index of and then just pass in another string and current culture, whatever, it's going to be an O of n times n operation in order to do that lookup because of the way that works under the covers, because a lot of pre-computation needs to take place whenever that needle is provided. I think we should actually start moving to a system where if you have a consistent needle that's used over and over and over again, like do the pre-computation on the needle and then have the APIs hanging off the needle, very specialized APIs that know exactly how to use that needle.
So personally, I'd be fine with that approach. Defer to Stephen being in the meeting, because I'm sure he would have more comments on that.
I mean, I don't understand, Diva, why you think that's better than overloads.
So memory extensions, we try to keep generic as much as possible. Like this is now tying memory extensions to something that is very specifically meant for one very concrete narrow scenario, which we have tried our damnness to avoid. Because it now means that when I say that I have some random byte array, which literally represents binary data, right? I call dot on it, and now I'm starting to see APIs that have nothing whatsoever to do with binary data, APIs that are custom tailored to ASCII scenarios. Like that's not really something that we want people to have to see in IntelliSense, for instance, if they're operating with like images in memory.
So, okay. Is there a way to do a 256-bit version of this? Or sorry, yeah.
If you had a 256-bit version, I'd be okay with that.
And then like also have this version, and then maybe put like 128 and 256 in the name or something. I don't know.
Well, I mean, char would be weird at that point, because why is char limited to 256?
Yeah, that seems like implementation detail, right? That should not be part of the API, right?
Like the algorithm exists for it. Like you can have an efficient 256 bitmap as well, so you can cover the whole byte. I'm not sure any of our users would use that because we, for the most part, these APIs really care about ASCII for the most part.
Yeah, but you have
Yeah.
you have a very restricted scenario though, that because you're working in the networking space, and your use cases are now going to touch things like I'm performing image manipulation, and I have a RAWs byte that represents, a JPEG, and now I'm starting to see networking specific APIs hanging off my JPEG type.
Well, you'd see it as an extra overload of index of any, which you presumably wouldn't be using in those scenarios anyway.
I mean, why don't we just add extension methods to object if that's the case?
Yeah, like the one virtue is it has ASCII in its name, which gives a strong association, but I don't like the notion of extending read-only span of byte for this.
Yeah, so I think what I kind of agree with Levi's Uber point. Like I think I don't like the idea of instance members on some sort of needle API. I think I would prefer a model that is like API shape-wise similar to what we have here, where it's basically static helper functions that may be extension methods over some data that we care about, or just static helpers. That seems more sensible. But I'm also not sure that the proposal as it's here with the read-only struct is the thing we would like to do. Like this is the evergreen problem that we have, right? Like the type representation for something that is ASCII only, which we don't have, right? And that is not just for read-only span of char. We had the exact same discussion for, oh, wouldn't it be nice if we knew that, this, RAWs of byte is actually UTF-8 versus ASCII versus some random buffer, right?
Well, it's not necessarily that, because the scenario is that you have some expensive computation that you just want to cache, right? Your index of any ASCII values type. Which, by the way, if that's cached, make it a class, not a struct, because it'll be faster most likely.
Well,
For
internally, this
128-bit
is
value.
Sorry.
I mean, it's
internally.
basic-
Sorry, go ahead, Sue.
You should go ahead. I'm sorry.
The internally, this struct is really just wrapping a single class of essentially what you're suggesting, Levi, which is an index of any searcher thing, which is the pre-computed needle, and then calls APIs on it.
Yeah.
How big is it though? Like, how big is the struct? I guess is the question.
If we wanted to minimize it, it would be 128-bit minimum, right? So 16 bytes.
But do we lose the caching benefits? Yeah.
You lose some benefits. For example, you can speed up the scalar path somewhat if you pre-compute some other things. So at the point where we were like, we can have an instance storing this state, then we can just pre-compute whatever we care about, not just the minimum.
Right, so
Yeah.
it's a pointer big because you're using it as a obscuration.
And at that point, like, just make it an opaque class. Like, the classes are generally easier than structs for people to use because structs represent generally primitive data. And cached data in general, like, it's going to end up on the heap, like all that good stuff. Just embrace it, make it a class. That would be my feedback on that.
I mean,
Because people
you
shouldn't be creating these over and over, right?
Exactly. So presumably these are mostly static values anyway, right? Because it's things you're parsing for, right?
Yeah.
And while I think x86 will pass a struct that is only one reference as a single register, I know that the like S3 whatever X will actually always copy the struct like to the stack and then pass the address of that, even if it's only containing one pointer. So the struct wrapping a class is it is not optimized on all architectures.
The other thing is, given the API shape right now, if I have a RAWs byte and I call index of any, new open parens, open quote, hello, close quote, close parens, that's actually going to be an allocation under the covers. Like a proper honest to God heap allocation.
Yeah, whatever the state is.
Yeah. which is unexpected.
Does this mean
So
you're
the-
not a fan of string values, Levi? I know you know that type.
I'm familiar with string values, yes. I am not a fan of it, correct.
So the suggestion there is essentially to change read-only struct to sealed class.
Correct.
Yeah, but I don't know. I have little, assuming we figure out a place to put the type, I have little issue with it with the index of any over Rust char, but the Rust byte one just feels just so wrong.
So, but what if it's in a different namespace that you actually have to import? I mean, this one is in systems. Everybody has an import for that, right? But if it's in a separate dedicated namespace that is dedicated for ASCII and you have to have a using for that, at that point, it seems fine if it shows up, right?
Yes.
I guess if you
Well,
do
still,
using system.text.ascii semicolon, then now all of a sudden Rust byte gaining a couple members that look like index of any ASCII values, which maybe would live in said namespace. But
I mean, I think to me that seems reasonable because you have, I mean, like what I don't like about Levi's proposal is that the way you call the APIs now drastically changes, right? Instead of calling them off of the span like you do in all the other cases, you now call them off of something else and pass the span in, right? That's why I kind of like the idea of keeping the shape, but just making the import conditional, right? Because I kind of agree that nobody wants these APIs for the most part. But if you need them, you probably need them. And then it's nice if things are just the same as everywhere else.
So my thought though is that extension methods are like a usability thing. Yeah, sure, consistency, but all the other versions of these methods take like a string or a car or an array, right? Think something that you can like easily create like inline. And this is just very different. And as someone who's probably going to use these APIs, I don't really care if it's just a normal static method.
I mean, the only thing I would say is like, I agree with you, but keep in mind that a lot of the code that you end up writing is going to be copy pasta from other places you already have done something similar. And I think it's nice if you get a compiler that says can't convert string to index of any. At least that's kind of like more helpful than, oh, sorry, I have no idea what this API shape is, or you're calling the thing with the wrong number of arguments, right? So the closer you are, I guess, between different areas, I think it's generally just helping people evolve code.
But if you're making an extension method, even if it's in a weird namespace, you won't get can't convert string to index of any. It would be can't find a method index of any on read-only span of byte or a suitable extension method. It's not going to tell you what the closest match was because there's not going to be a closest match. Index of any ASCII values is going to be there. Multiple byte options is going to be there as a value. So it's going to lose any notion of like, you gave me a thing that doesn't make sense, and here's what I think you meant.
Yeah, I'm not saying that. I'm just saying like, like imagine you have an existing code base that already has the import, right? You just add another, like, I don't know, parsing thing to it that you leverage from somewhere else where you happen to do it over strings, right? Then you get the benefits. I mean, yes, if it's a net new file, then you still have to somehow magically know that you have to have the using statement for this other area, right? But my point is just that a lot of the stuff that we do often is kind of adjusting or evolving code that used a less efficient representation, and then you go to something more efficient, and it's just, I mean, it's not that it's the worst thing in the world if the more efficient thing has a completely different shape, but I think if we can help to avoid that, I think it's generally better because it's just less specialized, right?
And that's fair. Like as long as it's in a different namespace, like my concern does fall a little bit. However, I do want to bring up that a few weeks ago in this very forum, we discussed ASCII APIs, and we were all in very solid agreement that they should be on a separate static class instead of extension methods.
Yeah.
I mean, this seems like it falls under the same category.
Yeah, like I'm, totally content with, ASCII dot index of any read-only byte of or read-only span of byte, because like you've said at that point, ASCII is very, very, very clear in the intention. It's not just showing up on every read-only span of byte that exists.
I'm fine with that too. Like, it's a good place to put other ASCII related. I mean, it might help with the discoverability of other read-only span of byte methods, right? That might be relevant to people mucking around with ASCII. Like, I get that discoverability is already kind of there with read-only span byte dot, but like to the earlier conversation, like, do we want to put a bunch of ASCII stuff there? I'm fine with not.
Yeah, I think the line that I've generally been holding is if you have an extension method on a type, that extension method should be generally applicable to all data within that type.
Yeah, that's fair. I mean, for the most part, we end up using extension methods mostly because of JIT reasons, right? So if we think of them as actual instance methods, then yeah, we would not put like super specialized things on core types, right?
Right.
So from the user perspective, you'd essentially end up with ASCII dot index of any span, comma, pre-computed needle instead of like an extension method on span. Is that what the suggestion was?
Right. Or either that or an instance method on the needle. Between those two, I don't really have a strong preference. And if you make the needle a class instead of a struct, it's very obvious to people that, like, hey, you're intended to instantiate this once and then store it somewhere for later usage.
Yeah. And I'm not entirely sold on the name index of ASCII values, but you know, we're over on time and my brain's shut off. So.
I mean, we tend to use the words, you know, map or bitmap for stuff like this.
Right, because really it's is there any use that we could have for this that is something other than index of any? And so if it, you know, ends up being, you know, set of ASCII values, right, then that tells you duplicates are being ignored and whatever, and then you can do index of a set. That's totally fine.
I mean, you could also use it as a split if you want to.
But
it depends on how much pre-computing we're doing specifically for index of any, I guess. But yeah.
Which
yeah,
namespace?
I mean, I assume what it's doing is getting rid of a whole bunch of is this out of range or whatever checks by doing it once and now saving we know that this is passed. It's the same as the like JSON encoded text of we don't need to ask anymore, is it valid UTF-8?
Well, the other thing too is you actually don't even have to do the work up front during class creation. You could say, okay, we have one set of optimizations that we do for index of any. We have another set of optimizations we do for split, and then so on. And you simply lazily perform the optimization the very first time the method's called.
Yeah, I mean, if you're gonna throw on chars that are outside of the ASCII space, you need to still do that in the constructor because you don't.
Yeah.
Delayed exceptions are very, very difficult to track down.
Right. So I mean, you could do one check in the constructor, and then you could, you know, do later optimizations as the need arises for them, and then cache them back in the class that was passed to you.
Yeah.
Just need 128-bit literals, right?
I mean, you know, fixed byte of 16, right?
Yeah, and if by ASCII it means ASCII 7, then which is 128, then that's just 4 ulongs. Like you can store that bit vector however you feel like it, whether it's vector 128, 4 ulongs.
Why is it 4 ulongs?
Because I was thinking uint.
2.
Okay. You could also just use one int 128 since we have that type now.
Yes.
Is there a literal for that though? Can I like write out like in hex like the whole thing in C#?
If you go pester Jared enough about it, maybe we could get one for .NET 8.
So if you actually need a sample of this, take a look at System Text Encoding's web, because they actually have a like bitmap struct in there internally that you might be able to rip off for this. That's very specifically an ASCII bitmap struct. I wonder why that scenario came up.
Oh yeah, Kevin's right. Totally meant Windows ulong. Yeah. Yeah, that's the save. Thanks, Kev.
all right, we're done, right? Like, this is not approved yet. We need to find a good names for the static class that is not going to be extension methods anymore.
Was there any big preference over needle being a class with instance methods on it for index of any versus something on the ASCII class which takes the needle?
I mean, I think on that one, really, it's, you know, doodle it out a bit and see which one feels like it reads better. Emo thinks that it being an instance off of the type is backwards of his mental flow. So
Yeah, what would
and
you
that's
call
fair.
the method if it was, like, hypothetically?
that's
Index
true.
of any. I
Well,
would call
you'd
it
have
index of any.
With the needle
You-
first? So it'd be
no,
needle
because if you
dot
called it
index
something
of.
like ASCII value set, then you wouldn't want to call then index of. It'd be like index of any from.
Yeah,
Exactly.
Expanded.
Find within.
Right, no, that's what I mean, right? So you end up with a different name because it ends up being reversed because you don't want to do needle dot index of.
Yeah,
No,
so,
you're right. It would be needle dot find within or something like that. But
yeah, so probably static methods on the ASCII class.
Which, by the way, is how Unicode does it.
I was about to ask,
Weirdly
like, do
enough.
we do anything similar to this for non-ASCII?
So that's kind of what I was getting at earlier. We've had quite a few customer complaints regarding the performance of string searching ever since switching to ICU for culture-aware scenarios specifically. And one of the reasons for that is whenever you call index of and then pass in, your needle, we have to do significant pre-computation over the needle. But then, like, as soon as the call to index of returns, like, we've lost all that pre-computation, right? Because you simply passed it as a needle parameter. We can't store it anywhere. So one of the things that we were looking into for that was to have a class dedicated for the needle you're searching for. Because that's also what ICU, used by Unicode, kind of wants the caller to do. They want you to create that once and then keep calling move next, move next, move next over and over again to find all the different matches. So that would necessitate us creating a special class for that. That said, given that string searching tends to be an iterator style pattern rather than just, return an index and then be done with your life, we would probably put methods directly on the needle at that point because we want the needle to be an enumerator or to be enumerable or something like that.
I mean, that would make sense to me because at that point you don't really need to match the existing names. But I'm not a fan of just for simplicity sake to say, oh, we have a needle type, and then all the operations are now suddenly inverted, and so all the common naming conventions we have don't apply, or you have to come up with a mechanism to invert them, right? Prefixing them with within or something, or suffixing them with within, which seems weird. But if you basically say like, oh look, you no longer call index off or last index off, you basically create something that gives you back an iterator in which you call move next on or something, then I think that would clearly warrant a different API shape anyway, right?
Yeah, and I think that's also partly because in the ASCII scenario, you can make some assumptions about, like, the first time you call index of any, it returns a value to you. Like, what do you do to skip over the thing that was returned? You just add one, slice, and keep going, right? Like, as soon as you're no longer dealing with ASCII, like, that's out the window. Like, the stride might be more than one byte or more than one character, and you simply don't know that easily unless the API is returning that value to you. So now you already have something that looks radically different than a standard index of method.
And since the German S set will match a double S, you can't just skip the length of the thing you were searching for because you don't know which one had the S set.
Exactly, which is why, like, we actually needed to rethink the API for non-ASCII.
That's why Switzerland's decision to drop the S set is the best.
So
So the iterator's interesting.
So do you already have
sorry.
the iterator API somewhere, or is it just something that you thought of but we never ended up shipping?
We never ended up shipping it. Like, we have something that can kind of, with really poor performance, mimic it, but it's not something that we actually did yet.
All right.
It just keeps getting punted because other stuff keeps coming up as higher priority.
So
Right.
I have to go, but I would say on this API, I wouldn't want to get too fancy, like with the instance methods on needle. Just like this looks pretty good. Remove the extension methodness and find a new class for it, right?
Yeah, I mean, they could go further and do the iterator pattern, but we probably would wait until we do the iterator pattern for ASCII and then backform it to here. Sorry, for Unicode and backform it to here. One concrete bullet that should be written down, Emo, is index of any ASCII values shouldn't be a nested type.
Right.
Yeah.
It needs to be its own top level type because someone needs to create it.
Are we
And it
still
should be a
good with?
class.
Yeah, it should be a class, definitely. Are we still good with returning nested types from memory extensions? If we just expect that people are going to for each over them or shove them into a var or something, and that they never really see the type name?
Iterators are always allowed to be nested classes, and then there are some other weird cases of when it's like super duper specialty and it's like 1% of 1%, then it can be nested. But we don't ever assume anyone does var except in for each, because that the call to get an enumerator and stuff is implicit.
Didn't we add an ASCII type somewhere? I thought we did.
No, we never added an ASCII type. We talked about it a few weeks ago, but it got rejected in review because there was too much work to do.
Well, bring in something smaller.
Yeah, absolutely. Like this, literally, we could bring that back as a very small type containing only this, and then build off of it piecemeal.
Yeah. It still helps to know where we go with this, but yeah.
I was talking with Eric T the other day about something very similar, because he wanted, similarly, we had a UTF-8 type where we tried bringing like 30 APIs at once, and the set of APIs was marked as needs work, but he's like, well, I just need one or two of them. Like, can we bring just that small set through, and then, you know, approve that? So do the same thing here, right?
Yeah.
For the ASCII type, was there any discussion what namespace that falls under?
Yeah, I think we didn't
I think
like
it was. I thought it was a system buffers text. It's in the recording.
Okay.
Yeah, system buffers text, system text. Either of those seem fine to me. I don't think it needs to go in system.
No. It's I think people were happy with system buffers, whatever, just because like it's operating on a buffer of data.
Yeah. I would prefer system buffers text over system. Also over system.text, because it's already kind of imported by a lot of people.
Yeah.
And this feels very specialized.
Yeah, system text is normally used for like text introspection, encoding, stuff like that, which doesn't really fall here, or doesn't really mesh here.
Right.
Do you need this to work on NetStandard 2.0, or do you just need a Net Core 8?
Core 8.
Okay.
It's also not a must-have. So the way the current implementations that don't have this, what we have is just a normal loop and then a hand-rolled bool 128 somewhere.
Yeah.
And do lookups into that. This is just way faster.
Tanner, wasn't there a proposal for like a bitmap 64 or bitmap 128 type a while back? Like I swear I saw your name attached to that somewhere.
I don't recall anything off the top of my head.
Okay.
But I also have like all of Workpage out of my head at the moment, so.
Excellent. As you should.
All right, then I think we're done for today because I need to go.
Thanks, everyone.
Thanks, everyone.
Yeah,
that
thank
was
you.
fun. Bye, Internet.
Juice.